John Belquist here, Intelligent Concrete. We're here to talk about one of my most favorite things to talk about, concrete. Duh! What we're really here to talk about today is a Q&A day. Q&A day! Locke Jackson, thank you, sir. All the way from Vietnam, I think? Or Asia? Something like that. Locke Jackson asks, right, Locke Jackson, what would be the result of a spray application of colloidal silica or the addition of colloidal silica plus Juno XP? Whew. This question got me all riled up, excited, because that is a great question and a great direction. Now, Locke, I'm going to answer this question two different ways. Juno XP plus colloidal silica admixture, spray on or not. Juno XP plus a colloidal silica hydrogel technology, mix in and spray on top. So let me dive into it. I think the concept, Locke, is absolutely brilliant. I was at a convention 6 months ago where one of the speakers was talking about alumina treated carbon nanotubes in a hydrated cement matrix with or without colloidal silica. And the whole idea is that putting these carbon nanotubes into the hydrated cement matrix is almost like putting mouse hair through a tennis net. You have a very porous sponge which makes up our hydrated matrix, and you have these very, 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 very fine nanotubes, and the biggest problem with our hydrated cement matrix is it is a dense sponge with a lot of pores in it. So are we getting a true efficient bond? Are we getting a mechanical or chemical bond between our nanotubes and our hydrated cement matrix? And with the standard mix, as we know with carbon nanotubes, they don't really like to bond to things as much. That's why we functionalize them. So we really have to rely on that mechanical bond or that dense hydrated cement matrix. And with the standard mix, you might not get that. By using colloidal silica, what we saw was a densified hydrated cement matrix that could grab onto those nanotubes and then transfer those catastrophic loads that would cause a catastrophic failure, either shear or tensile. They were absorbed by the carbon nanotubes, and we saw those higher loads. So ultimately, I think we would see the same thing. Juno XP, if y'all don't know what it is, it's an alternative supplementary cementitious material made by Surface Tech in La Jolla, California, and it's a two-part material. It's a traditional pozzolanic material which consumes calcium hydroxide to create more of the backbone of concrete strength, the calcium silicate hydrate, and then some mineral component which has the same chemical makeup as the backbone of concrete strength, the calcium silicate hydrate, has a fibro-like morphology, and it has a tensile strength greater than para-aramid fibers or Kevlar fibers. And what we think is happening with that stuff is that it does bond to the hydrated cement matrix because it does have that same chemical makeup as the calcium silicate hydrate. That being said, it is still of a fibromorphology, and it still does require some mechanical bonding as well as chemical bonding to that hydrated cement matrix. And by using something like colloidal silica, whether you spray it on after the fact or mix it into fresh concrete, you're ultimately doing that, creating that densified hydrated cement matrix that can anchor on to that mineral component of the Juno XP to get you more of that tensile and shear capacity. So the other thing, and the same thing goes for spraying it on, you'll get that migration, yada yada yada, berta. Locke works with a colloidal silica hydrogel technology. I believe it's Acuron 2000, 3000, 7000, 300, and then the Conquer B52, all of which are centered around this idea of colloidal silica hydrogel technologies, where you have a catalyzed or manipulated colloidal silica. So it's not your bare-based colloidal silica, it's a modified version that when it hits a change in pH, normally based off of the cement simulated pore solution, it will start agglomerating into these three-dimensional structures that retain not only water, but also that silica or that nanosilica, so that one, you seal up the cracks in your concrete or the pores in concrete, but you're also going through that pozzolanic reaction because not only do you have water in that hydrogel, but you also have that calcium oxide or that calcium hydroxide as well as your silica to give you that pozzolanic reaction. So it goes from a sealing to a healing. And same thing with the colloidal silica, except for the fact that we might see more benefit by using the colloidal silica hydrogel because it does retain some of that water for long-term hydration, as opposed to the colloidal silica, which, especially some of the smaller ones, they could burn up pretty quickly, and you don't have that silica surface area for long-term durability, long-term reaction. So I definitely think using a colloidal silica hydrogel, whether we're mixing it up into the mix or spraying it on top, will be total aces for the Juno XP. So thanks for the question. Thanks for joining us today. Don't forget to like and subscribe. Ding that bell for notifications. Go, go, great. Bear.